Hello guys, welcome to this machine learning step-by-step tutorial. On this tutorial, you are going to learn how to implement multiple linear regression in Python. Previously, I have made a video tutorials on a single linear regression model and how to implement it to predict the student's test score. You can watch the previous video tutorials before you dive into this multiple linear regression models. Don't forget to like, share, and subscribe, and write your comment under the comment sections in this video tutorial. Okay, before we dive into the implementations of multiple linear regression model in Python, let's understand what is multiple linear regression in Python. Multivariable or multiple linear regression is a machine learning algorithm that is a statistical model used for modeling the relationship between a dependent variable and multiple independent variables. Why we call it a multiple linear regression? Because we may have multiple independent variables to implement this linear regression. But if you are implementing a single linear regression, you can have one independent variable only. So in this tutorial, I will show you how to implement using multiple independent variables. This tutorial also extends the concept of simple linear regression. And where there is only one independent variable, you can watch it, the previous tutorial, to situations where there are two or more independent variables that may affect the dependent variable. In this tutorial, I will demonstrate how to perform multiple linear regression using Python and the popular scikit-learn library. I will use a synthetic dataset for simplicity also. So in multiple linear regression, the goal is to find the linear equation that best describes the relationship between the dependent and independent variables. The dependent variable always denoted as y, that is called a predicted variable. And the independent variables often denoted as like x1, x2, etc., up to xn. So the linear equation takes the following formula. This is the linear equation. If you remember the mathematical linear equation, so we directly implement that mathematical linear equation in machine learning to predict multiple linear independent variables. Okay, so this equation, this is the called the I mean, y is called the dependent variable that's going to predict or explain x1, x2, and up to xn are the independent variables, the futures or predictors that's going to predict the dependent variable. So we call them predictors, okay, or future variables. And b naught or beta naught is the intercept, the value of y when all independent variables are 0. That is the value of y, or that is called intercept. And b1 or beta 1, beta 2 up to beta n are the coefficients that represent the x or the independent variables. That the change in the y for 1 unit change in the corresponding independent variables while holding all over variables constant. So, and the end one, which is error, this represents the error term, which accounts for the variability in the y that cannot be explained by the linear relationship with the dependent variables. Okay, so we are going to implement this multiple linear regression using a dataset, synthetic dataset in this tutorial. Okay, so I'm gonna show you step-by-step implementations in this tutorial. The implementing multiple or multivariable linear regression involves several steps, including data preparation, modeling, and evaluation. Here, I will provide a detailed implementation example in Python using the scikit-learn library. Scikit-learn is the most popular machine learning library, and I will use a sample dataset to illustrate the process and make sure you have a sci-kit on your computer. And if you didn't install yet, you can install using pip install scikit-learn. And the step 2 is import libraries. Yeah, once you install the scikit-learn or other necessary libraries for your machine learning implementation, you can import all required libraries first in the first step. For example, Numpy is important, especially to generate synthetic data. Pandas to create a data frame. Matplotlib, this is also help us to visualize scatter plots to understand the relationship between each independent variables and dependent variable. And import the train test split method from model selection in the scikit-learn library, because this help us to split our dataset into training and testing sets, and the linear regression model from linear model. And you can import the mean squared error and R2 square. These functions or methods help us to evaluate our performance of the model. Okay, once you import all the required libraries in the step 2, we go to the step 3. Step 3 is about loading your dataset. If you have a dataset in Excel or CSV file, you can import your dataset. If you don't have any dataset, you can create a synthetic dataset. But in this tutorial, I will create a simple synthetic dataset. So in this case, I just set a random seed for reproducibility and generate random data for x1 and x2. In this tutorial, I only use two independent variables. You can have more independent variables, but if you understand how to implement using two independent variables, that is the same to implement more than two independent variables in multiple linear regression model. So here I have 100 number of samples. So I just generate 100 samples, random sample data for x1 and x2, and also create y for random by using the equation. The equation is actually I have two independent variables, 2 multiplied by x1 plus 3 multiplied by x2. Those are the coefficient variables, plus NP random int minus 10 up to 10, number of sizes here 100. So this is the y, or the predicted variables. So I have created the data frame for the 3 variables, independent and dependent variables. And let me show you the first 5 rows. Okay. Yeah, these are the data I have created, the synthetic data. I have x1 and x2, the independent variables. Y is going to be predicted or dependent variables. So the x1 and x2 are the predictors for y. So these are the variables it's going to I'm gonna use for predicting or implementing multiple linear regression model. And once you create or load your data sets into data frame, you can understand the relationship between x1 and y and x2 and y by plotting scatter plots. So variables relationship with scatter plots. Let's visualize the relationship between the independent variables x1 and x2 and the dependent variables. You can use the scatter plot to plot the scatter plot is very important to understand and the relationship between multiple independent variables and dependent variables. So here the blue represents the x1 versus y. So you can see that x1 and y has a positive linear relationship because it's just increasing the value of y when the value of x1 is increasing as well. The same is true for x2 versus y. The yellow represents that it has a positive relationship between the x2 and y. So when the value of x2 increases, the value of y or the dependent variable going to increase as well. Okay, so this is the better thing to understand the relationship between the independent and the dependent variables before we dive into the model prediction. If they don't have a relationship, a linear relationship between the dependent and dependent variables, so you have to change this linear regression into polylinear regression or other linear regression methods or models. So in this case, we have a positive relationship between the two independent variables and the dependent variable. So the scatter plot visually represents the relationship between x1 and y. The blue represents x1 and y. And x2 and y, the yellow represents x2 and y. So they have a positive relationship, as you can see on the scatter plot. And they show how the dependent variable y varies with changes in the independent variables x1. So we can see that so the dependent variable y is depend on the independent variable x and y, because when the x1 and x2 increases, the y also increases as well, as you can see, because y is always dependent on the independent variables x, but x1 and x2 doesn't depend on the y because they are independent variables. Okay, once we understand the relationship between the dependent and independent variables, we can split our data set into training and testing set using train test split method from scikit-learn. So we first separate our data from data frame, and we have to just separate independent and dependent variables. So independent variables are x1 and x2. So we can just get x, just store in x variable, and y is always the predicted variable, but the x represented the futures or predictor variables, always called independent variables. So you can split the x train, x test, y train, y test, and you can pass the x and y into train test split method, and you can split this data into training and testing set, which is the testing set is 20%, but the other 80% is the training set. You can see put random seed into 42 or 0 or whatever. Okay, once we split our training, our data into training and testing sets, we can create a training model and train our model to feed the data in, the model to the data. So this is just simply create a linear regression model, and we can pass the X train and Y train into the model to feed to the data. Okay. Once we train our model, that is the best thing, and make predictions and evaluate the performance of the model. Use the training model to make predictions on the test set and evaluate the performance of the model. And first, you have to make predictions on the test set, because we splitted our data into testing and training set. The training set always used to train our model. Once we train the model, we can test our model by making a prediction using the test data set, X test. And we can measure the performance of the model using mean squared error and R2 square or R2 score. Then if our model performance is good, we can predict a new data to predict the futures of our data. Okay, so in this case, we can see that we can the result of the prediction of our X test. Yeah, these are the X test. So we can see we have these prediction results, and we can measure the performance or evaluate the performance of the model using mean squared error, y-test. We pass the y-test and which is the predicted data, into mean squared error, and we also pass y-test into y-pred into R to score from matrix, and we can understand that 33.5 is the mean squared error, and 1 is the R squared error. Okay, so we can understand that we can conclude that our model, based on that mean squared error, a measure of the average squared difference between the actual and predicted values, the actual value y-test and the predicted value. So the lower the mean squared error, which has a better model to fit. For example, this is 33.5 is the lower mean squared error, which means the error is lower, which means the model is better. So in this case, and the R squared error or R2 score is a measure of how well the model explains the variance in the independent variable. I mean the dependent variable. So basically it ranges from 0 to 1. With higher values indicating the better fit. So in this case, 1 represents that the model is 100% fit to the data. So the model is better to fit, and if the R squared is 0, so the model is not better to fit. So in this case, our model is good. The model performance is good, indicating that the mean squared error is lower and the R squared is higher. This is the most important thing. If in this case, if your model performance is lower based on the R squared and the mean squared error, you have to check back to the data, and you have to, if you may have a small set of data, so you have to collect more data set. You have to check the relationship between independent and dependent variables. If they may have positive relationship or linear relationship, so you have to change the model into another algorithm or machine learning model than using multiple linear regression model. Okay. And we can also explore the model coefficients. You can also explore the coefficients and interpret the linear regression model to understand how each independent variables are influences the dependent variables. So you can use model this to understand the coefficients and intercept of the model. Okay. So that's it, and I have successfully implemented a multiple linear regression model in Python using scikit-learn. You can now apply this knowledge to your own data sets and projects, and further explore advanced topics in regression analysis as you become more comfortable with the basics. So I will recommend you to implement predicting house prices. You can obtain data from online open data sources, and you can learn more how to predict the house prices using multiple linear regression models. I hope you enjoyed in this video tutorial. Don't forget to like, share, and subscribe, and also write your comments under the comment sections of this video tutorial. Thanks for watching now.